Hello everyone. We recently learned about periods and amplitudes and phase shifts and vertical shifts and what they look like on the graph. Now let's see how to find them straight from the formula. Say you're given a generic trigonometric formula. Could be sine, cosine, or tangent, or even secant and so on. A, in this formula, will give you the amplitude of your function. B gives you the period of the function, specifically 2 pi over b is the period. C gives you the phase shift, how much the function moves from left to right. Specifically, phase shift is c over b. And D gives you the vertical shift, how much the function moves up and down from the baseline. Let's see how all this works. Say our function given is y is equal to 5 sine 3x. Now, a normal sine function, this is our normal sine function, has an amplitude of 1, and it ranges from 1 to -1. It has a period of 2 pi, because it goes through one full revolution, and then repeats after 2 pi radian, or 360 degrees. If we multiply our function by 5, we see that our amplitude becomes 5, because our graph will now look like this. This is equivalent to multiplying the y value at every point by 5. So now the new greatest distance from the crest to the baseline is 5. What does it mean when we multiply 3 by x? What we're doing is for each x value, we're giving it the y value of the x value that is 3 times itself. So our x value here, pi, will take the y value of 3 pi, which is also 0. The x value of pi over 2 will now have the same value as the x value of 3 pi over 2 used to, which is -1. So we see our function is squishing inwards. So now it looks like this. And our new period is equal to 2 pi over b, or 2 pi over 3, which is smaller than our old period by a factor of 1/3. Let's look at some vertical shifting. Here's our function. Y is equal to cos x plus 4. Our usual cosine function looks like that. It starts at a y value of 1, and its period is 2 pi, or 360 degrees. Let's give this graph a little more room. This is y is equal to cos x. Now, when we add 4, that is, d is equal to 4, where d is the vertical shift, what we're doing is effectively moving this entire graph upwards by 4 units. So now, the new baseline will be 4, and our graph will look like this. And everything else has remained the same. The period, the amplitude, and the phase shift is all the same. It's just been shifted vertically. Alright, now let's look at some phase shifting. Say we want to find the graph of y is equal to sine x plus pi over 2. It appears that our a and b values are 1, so we know the amplitude and period are regular, and d is 0, so there's no vertical shift. But it looks like we have a phase shift of pi over 2. What does this mean? Let's try to graph it out. Our normal sine function looks like this. This is y is equal to sine x. Period is 2 pi, amplitude is 1. When we change this to x plus pi over 2, it's equivalent to moving this entire graph to the left by pi over 2. Let's see how that works. At 0, 0, we have y is equal to sine pi over 2. So our new y value at 0 is 1. At pi over 2, we have y is equal to sine pi over 2 plus pi over 2. That's sine pi, which is 0. So our new pi over 2 value is 0. Meanwhile, at sine pi, we have y is equal to sine pi plus pi over 2. That's 3 pi over 2. So at sine pi, our new value is -1. So our graph now looks like this. Basically, it's just been turned into a cos graph. So sine and cosine are the same function, shifted a little bit to the right and left.